This video is going to go over how to describe functions in 4 different ways. It's going to describe functions as linear or nonlinear and proportional and non-proportional. A few things to go over in the beginning is some vocabulary. First of all, a function is linear if it makes a line. If it makes a straight line, so let me add that. The graph is a line, but it needs to be straight. The equation would also be written in the format of y equals mx plus b. Note that there's not an exponent with the variable. It's just x. Then here is an example, y equals negative 3x minus 4, y equals 5x. All of these two are both linear because it's just a number with a variable. If a graph is not a straight line, then it's not linear. Not a straight line. That is going to be your only determining factor. And this exponent is what is going to cause that to happen. When there is an exponent, that will cause your line to bend. Or make a curve when there is an exponent. Then a linear function, so we've already determined that it's straight. So a linear function is proportional if the graph passes through 0, 0. So this is an extra thing to look for. Proportional if it passes through the origin. Okay, if a graph only has y equals and then a number with x, that is what you're looking for to be proportional, because it has no y-intercept, or the y-intercept is 0. This one is not proportional because it has this added extra number and not just the variable. So here's an example that's done for you that you could check. If I have an equation that just says y equals x plus 2, automatically I know that this is not proportional. And I know it's not proportional because it has this plus 2. That's going to make it not proportional. It is going to be linear because the variable just has the letter. Okay, so then there's a table. This is how I could test it. The part I'm testing is x plus 2. I can pick any numbers I want and put it in the spot of x and then do what it says, add 2 more. Then I get my y's or my outputs. So then I get ordered pairs. So if I chose negative 2, I would say negative 2 in the place of x. Negative 2 plus 2 is 0. Then I would have an ordered pair. If I put 0 in the spot of x, it would say 0 plus 2. I get 2, so my ordered pair is 0, 2. I could do that for any value of x to get my output. Then I could come over on the graph and I could graph now these ordered pairs. So, again, matching up with the equation, since it did not pass through 0, 0, that means it's not proportional. Did not pass through 0, 0. And that is the big thing that makes it not proportional. Oops, I spelled that wrong. not proportional. It does make a straight line. And that's because there was no exponent with the variable. So this is linear for sure. And linear just means it's straight. Okay, so on this last page, we're going to look at some examples, and all it says is write the word linear, proportional, or nonlinear. So this first one, I'm going to test out. I'm going to look, does it pass through 0, 0? Whoops. Does it pass through 0, 0? And did it make a straight line? So those two things are yes, proportional, and linear. Now, if I only have an equation to look at, I could test this out and just see, or I can look at the things that I've been told about. Since this has a y-intercept of positive 5, that makes it not proportional. It's not proportional because the y-intercept is a 5. And then the other thing that I'm looking at, it is going to be linear because it just has the variable with no exponent. The next one we're going to look at, it says y equals 8x squared. Right away, I know this is not linear because the x has an exponent with it. That's going to tell me right away. Because of that exponent right there, that's all I need to look at. And so I would just put nonlinear. And then I don't even need to worry about if it's proportional or not because it doesn't even make a straight line. The thing that I'm concerned with is that there's an exponent. Then the next graph actually is a picture of something similar to this equation. Because that exponent, if I chose negative 3, I could get a positive 9, or if I chose a positive 3, I could also get a 9. That's what happens when you have exponent on there. So again, that's the first thing I'm looking at. Is this linear? No, it does not make a straight line. So then I'm just going to stop, and I would put not linear. And because that it's making the bend or the curve, and that's all brought about because there would have been an exponent in the equation.